Okay, so now that we're really good with Leibniz notation, let's go through and use the prime formula for the chain rule. So again, that formula stated, so let me just write both of these up here. So we had dy over dx equals the derivative of y with respect to u times the derivative of u with respect to x. So there's the Leibniz. The prime one said that dy over dx is the derivative of the outside function with respect to the inside times the derivative of the inside. Okay, so one way, if we're doing this, find the derivative of cosine to the fifth x. So I can rewrite that just so I get it in a way where you can easily see how this is going to be using the chain rule. It looks like that. So we don't have a derivative formula for cosine of x to the fifth power, but I do have a formula for cosine of x, so my inside function, and I do have a formula for x to the, or u to the fifth power, something to the fifth power, okay? So again, we could go through and use Leibniz notation. I'm gonna do that really fast. So if I did that, dy over dx, so that's gonna be the derivative of y with respect to u, so that's 5u to the fourth, times the derivative of u with respect to x, so negative sine x. But then I'm having to go through, and this piece here, I have to still go back through, so I'm going to write that negative sign in front, or that negative in front, but I'm still going to have to go back through and put in what u was. That is essentially finding the outside function, derivative of the outside function with respect to the inside function. So we can end up kind of going through and skipping a step by doing it the prime way, but it is important that you understand how these all mean the same thing. Okay, so if I was doing it the prime way, so here we'd have our outside function is going to be that x to the fifth power, okay? So if I was doing that, that x to the fifth power would be 5, and then, so 5 times something to the fourth power, if I did that. So that's something, that inside function is cosine of x. So again, what we're doing here is you're basically visualizing, here's my outside, something to the fifth power. So something to the fifth power is 5 times that something to the fourth, times the derivative of the inside. So that's where that negative 5 cosine to the fourth x sine x comes from. So again, it's that if we had this, here's our inside, here's our outside. So if I take the derivative of the outside function, that's going to be 5 something to the fourth power. So that something is the inside times the derivative of the inside. So let's look at another one. So here we'd say our inside function, so our g of x function is the square root of x. Our outside function is the tangent of x, okay? So if I were to find this derivative, okay, so it's the outside function, so the derivative of the outside function is secant squared with respect to the inside times the derivative of the inside function, which is 1 over 2 root x. So this would be secant squared root x all over 2 root x. So again, if I went through and did this the other way, and you can choose whichever method makes the most sense to you. If I set this up, I'd have u equals the square root of x, y equals the tangent of u, so du over dx equals 1 over 2 root x, and dy over dx, dy over du equals secant squared of u. So dy over dx equals dy over du, which is secant squared of u, times du over dx, which is 1 over 2 root x. And then I have to go through and substitute in what u was. So u was the square root of x. So you still get the same answers. So again, whichever way makes the most sense to you is what I would recommend using. Okay, so now let's look at where we have to, a problem where we're going to have to apply multiple rules. So find the derivative of 2x plus 1 to the 5th power times x cubed minus x plus 1. Okay, super yuck. So the first thing that I see is I have two things that are getting multiplied together. So the first thing that I'm going to use is the product rule. So product rule, dy over dx equals f of x. So the first function times the derivative of the second plus the second times the derivative of the first. Okay, so I've got 2x plus 1 to the 5th power here times, okay, so I'm going to have to apply the chain rule here. So I've got my inside function is this, and my outside function is just something to the 4th power. So I'm going to go through and I'm going to use that, I'm going to try to use that other way. So the other way was, so it's going to be the outside function, so it'd be 4 something cubed, and that something cubed ends up being x cubed minus x plus 1 times the derivative of the inside, which is 3x squared minus 1. Plus x cubed minus x plus 1 times, okay, again, chain rule here. Inside function is this guy. So the outside is something to the 5th power. So something to the 5th power, that derivative is 5 times that something to the 4th power times the derivative of the inside, which is 2x. And then you guys, I'll leave it to you to, if you want to go through and FOIL this or factor this out even more, but you can leave it for here right now.